Today's lesson is called exponents. For the end of today's lesson, you'll know what an exponent is, as well as how to simplify an expression involving one. So, an exponent. An exponent is this tiny little number right up here. Now, with an exponent, you always have to have a base, because your base, you're going to be multiplying it by how many times your exponent is. Since my exponent is 4, that's why I have 1, 2, 3, 4 3's. Then what are we doing? We are always multiplying them. So it's 3 times 3 gives me 9. So those 3's are gone. Multiply it by 3 again. I get 27. Multiply it by 3 again. I'll get 81. That's where my 81 comes from. So our exponent is telling us how many times we need to multiply our base by. And this is read as 3. So 3 right here to the 4th power. What power is it? 4. So 4th power, it's above it. It's a higher being. So I need to write down the directions. And we're going to try to solve number 1. So we have to rewrite each power as repeated multiplication, like how I rewrote it up here. Then you need to evaluate it, give me an answer. So we're dealing just with 5 to the 2nd power. What is the answer going to be? Well, you should have noticed. This is 5 to the 2nd power. So that means I have my base of 5 once, twice. 2 times. Why 2 times? Because I'm to the 2nd power. And then what are we going to do? We're going to be multiplying them. So what's 5 times 5? And we get 25 as our answer. Now, go ahead and try to do number 2. If you notice, number 2 is very similar to our first example. Why? Because it's to the 4th power. So how are we going to be expanding it out as repeated multiplication? So you should have noticed, it's to the 4th power, so I have 1, 2, 3, I have 4 of my bases, so 4 2's. So what I need to do, I need to multiply them now. So 2 times 2 gives me 4, times 2 gives me 8, times 2 again will give me 16. So I think my answer is? My answer is 16. So all we're doing is we're expanding it out as repeated multiplication, and then we're evaluating, we're figuring an answer. So now I'm going to try to do number 3 and number 4. What are they going to look like? So for number 3, it's 10 to the 3rd power, so I should have 3 different 10's. Why 3 different 10's? Because it's to the 3rd power, so I take my base. It's once, twice, 3 times. Now, what's 10 times 10 times 10? So let's see, 10 times 10 gives me 100 times another 10 is going to give me 1,000. So you notice something there? If I take a look, I have my 10, so I keep multiplying it. I have 1, 2, 3 zeros. How many zeros do I end up with? 3 also. So with the 10s, be careful. Basically all we're doing is adding a 0, so there's a little trick to the zeros. So I get my answer of 1,000. Then we look at number 4, 12 to the 2nd power. So what's 12 to the 2nd power? That means it's just 12 times 12. And what's 12 times 12? 12 times 12, everybody? 144. Now in your notes, I need power, verbal phrase, and meaning. So whenever we see a little 2, our power of 2, there are 2 different ways of saying it. We can either say it's 7 to the 2nd power, or we can call it 7 squared. I'll use either way, but the same thing though, it still means the same thing. It's just 7 times 7. 1, 2. There's 2 here, so I should have 2 terms right here. But remember, there's 2 different ways of saying it. Either the 2nd power or squared. Now, I have 5. I have my little power of 3. That means it's either 5 to the 3rd power or 5 cubed. So once again, 2 different ways of saying it. 2 different ways, still same exact meaning. I have a 3 right here, so I have 1, 2, 3 of my 5's. I'm just expanding it out through multiplication. Now for our example 9, has an exponent of 4, so it's 9 to the 4th power. So since there's a 4 right here, I have 1, 2, 3, 4 times expanded through multiplication. Now, for any other power, it's going to be that number to the whatever power. So for example, if I have 9 to the 5th, it's going to be to the 5th power. The only special cases are 3 and 2. Everything else is just the number power. 4th power, 5th power, 6th, 7th, 20th power. All it is whatever number put a little th in power. So go ahead and write the directions. What we're going to be doing, we're going to be substituting in a 4 for whenever we see x. So go and try and simplify and see what this is going to look like. I'm hoping that the first thing everyone did was put in our parentheses, so it's 4 to the second power. Now if it's 4 to the second power, that means it should be 4 times 4. Why? Because it's to the second power, expanding it twice. So it's 4 times 4. 4 times 4 is 16. So 16 is going to be my answer. Now let's go and take a look at example number 2. Now this one, where's my x? My x is actually my power. So how do we plug this in? It's going to be 10 to the 4th power. So how should this look? This should be 4 times, oops, sorry, not 4. It should be 10 times 10 times 10 times 10. Now, we can multiply this out. So let's see, 10 times 10 is 100, times 10 again is 1,000. And then multiply it by 10 one more time, and I get 10,000. Now, you can do all this work, or if you noticed, I have 1, 2, 3, 4 of them. So if I put a 1, I can do 1, 2, 3, 4, and what do you get? You get 10,000 as well. That's a little trick when it comes to zeros. You can just add the zeros to the end. Now, go and try to do number 3 and see what you come up with. Once again, I hope I see parentheses. Parentheses 4 squared times 4. Now, what do I do first? This is your big question mark. What do I do first? Well, let's look at PEMDAS. So, do we have parentheses? Yes, but can I simplify that any further? No. So parentheses are gone. What's my next thing? Do I have exponents? Why, yes, I do. So let's expand it out. End up with 4 times 4 times 4. Now we're going to multiply. We just go left to right. So let's see. 4 times 4 is 16. Times 4 again is going to give me, let's see, 16 times 4, 4 and 2, 64. So 64 will be my answer. Now, let's see if we can do number 4. Number 4 is a little tricky. Let me look at number 4. So here's my x. So I put in my parentheses 4 to the 1st power. Now, what's my power? 1. So how many times should I see 4? I should see it once. So 4 to the 1st power is just equal to 4. It's just equal to itself. Because all it is the 1st power should show up only once, and that's what it does, only once. Now go and write down the directions, and go and write down example number 1. I'm going to show you how you're doing this for write using exponents. Now before we started with x squared, and that became x times x. Now we're taking this and we're going to be changing it into an exponent. So let's see how we do this. So remember, I need a base and I need an exponent. So let's find my base. My base in this case is going to be r. So I have r, that's my base. Now I need to find my exponent. Let's count how many r's I have. I have 1, 2, 3, 4 r's, so it's r to the 4th power. Now, I also have these s's. So s is going to put a base, so I put an s right next to it. Now, how many s's do I have? 1, 2, so it's s to the 2nd power, or s squared. So I've found my answer. That's all we're doing. We're counting how many we have of each base and changing it into an exponent. So go ahead and try to do number 2. See if you can figure it out. Now let's take a look. I have this negative 7. Are there any other negative 7s? No. No other negative 7s, so that means it just comes on down, negative 7. Now let's see, I have 2 different a's. So I know a has to be a base. How many are there? 1, 2, 2 bases, so 2 is my exponent. And take a look. I got a b. Are there any other b's? No. So my b just comes on down, and that is going to be my answer. Now, go and try to finish up number 3. Here's a tricky part though. I have a negative 5 and a 3. What do you think is going to happen to them? Now if you notice, we have these little dots in between. What does that mean? That means technically we are multiplying. So if we're multiplying, what do you think is going to happen with this negative 5 and this 3? Well, we'll just do negative 5 times 3. What's negative 5 times 3? So I have negative 15. So I have my numbers gone. Now I take a look. I have x's, so I have my base of x. How many do I have? 1, 2 to the 2nd power. Then I take a look. Do I have any other extra variables? Yes, I do. I have that y, so my y comes on down, and that is going to be my answer. Now go ahead and write down these examples. Big key thing here, we're not going to simplify. We're just going to expand out the expression to multiplications. We're going to be multiplying, just setting up how we're going to be multiplying these. That's all we're doing. Do not simplify them. Go and write down example number 1 as well. Now looking at example number 1, first thing you should notice, we have these parentheses. So what is that telling us? That's telling us that it's -7, how many times? 4 times. Now since it's in parentheses, my -7 should also stay in parentheses. So see what this is going to look like. It's going to stay in those parentheses. So when I expand it out, I'll be using parentheses. I don't want to see -7 dot -7 dot -7. Not like that. We got to stick with the parentheses. Now, discuss your groups. What do you think 2 is going to look like? Is 2 going to look like that? What do you think? Now with 2, we've expanded it. But here's the key difference. Here, the -7 was in parentheses, so it was -7 once, twice, 3, 4 times. In this case, are there any parentheses? No, there are not. So what happens? My negative comes out in front, so technically it's only 7 to the 4th power. That's why I have 1, 2, 3, 4 different 7s. That's why you have to be very careful whether or not a number has parentheses, because it makes a big difference, especially when you're dealing with negatives. Now, go and try to figure out number 3. With number 3, once again, you should notice I have some parentheses. So it's 5y, how many times? Twice. So it's going to be 5y times itself 5y. I don't see 5 and y squared, not like that, or 5 squared y. Since it's in everything in the entire parentheses, it's once, twice. Everything inside the parentheses multiplied by itself. Now I'm going to try and do number 4. Number 4 again. What do you notice? There are no parentheses. So what does that mean? It's technically only y to the 2nd power, because that power is only with y. So my -3 comes on down, and then I have just y squared left over. So I have 1, 2 y's. Be very careful whether or not it has parentheses or not. It makes a big difference in how we expand and multiply these problems. Now go and try to do number 5. So what do you notice? I notice it has parentheses. So that means it's me -3y times what itself? -3y. I want you to notice the difference between number 5 and number 4, number 2 and number 1. How are they set up differently? If you notice, there's going to be a big difference in our answers. If we look at number 4, it's going to end up equaling a -3y squared. If we expand this out again, positive, this ends up being 9y squared. These answers are totally different, so be careful. Now, go and try and figure out number 6. So, you should have gotten x plus 8 times x plus 8. Why? Because we have those parentheses. Everything inside this parentheses, how many times? Twice. So be very careful of the parentheses. So go and write down the directions. We're going to be simplifying the following and go and write down example number 1. Now, looking at example number 1, you should notice there are no parentheses. So what does this mean? Technically my negative is going to come on down. So I have a negative, then it's technically 4 to the 3rd power. So 4 times 4 times 4. And now we just simplify. So I know this is going to be a negative. Why? Because there's only one negative up in front, so I have a negative. So let's see, 4 times 4 is 16 times 4 again. Let's see, 4, 2 is 64. So we get -64 as my answer. Why? Because remember, there's no parentheses. Since there's no parentheses, that means this little parentheses just comes on down, and we're just left with 4 to the 3rd power. Now, go and try to solve number 2. Now with number 2, we do have parentheses, so technically this is -4 times -4 times -4. So let's see what my answer is going to be. These two turn into a positive. In this case, this turns into a -64. Be careful. Sometimes parentheses make a difference. I want you to really make sure that you're using these parentheses and paying attention. So they happen to work out this time, but it doesn't always work out. Now, looking at example number 3, what are we going to be using? Don't forget, you'll be using PEMDAS. So go and solve number 3. So So first off, I need to do parentheses. So it's 6 minus 2. I have 4. 4 squared is equal to 4 times 4, which is going to give me 16. Now, let's look at number 4. Once again, don't forget your PEMDAS. So let's go and solve this. Now, do I have any parentheses? No. Exponents? Yes, I do. So let's see, my 6 stays the same, my negative stays the same, but I have my 2 squared, which is 2 times 2, which will give me 4. So I bring down then 4 with 6 minus 4, I get 2. So 2 is my answer. So I'm going to write me a 2-sentence summary. We learned about exponents, bases, how to expand them, how to change a written expression back into exponents. Tell me what you learned.